Today we are talking about the topic of Surds. Before we start today's lesson, can you make sure you subscribe to the channel and turn on the bell notification? Thank you. The definition of surd is any whole number that is not a square number, such as 3. The root of this number is known as surd, or the multiples of that root. You see, root of 4 is not a surd because it's a square number. Root of 16 is not a surd because, again, 16 and 4 are both square numbers. Root of 5 is not a square number. So is root of 15, 3 lots of that number. These are surds, whole numbers that are not square number or multiples of these. There are laws of surds. There are 2 laws. Law number 1 is when you multiply a surd, say root of A times root of B, you can write this as a 1/3 by writing root of multiplication of these 2 whole numbers together. Or vice versa, you could split a number into 2 numbers and separate them as 2 surds. And law number 2 is when you divide root of A by root of B. I would write this as a fraction first. Root of A divided by root of B. And that can be again written as square root of A over B. So if there are times, we times them, put under the root. And if it's divide, we divide them, put under 1 root. Now, the application of surd is first simplify surds and then rationalize, and further question regarding simplifying. Now let's simplify. Simplifying surds. For simplifying surd, you need to know your square numbers. For example, 1 squared, 2 squared, 3 squared, 4 squared, etc. For secondary schools, they are expected to know up to 15 squared by heart. I want to simplify root of 12. So I look for the biggest square number that I can divide 12 by. So that would be 4 times 3. And I can now split using law number 1 backwards. Would be root of 4 times root of 3. But root of 4 is not a surd, it's a square root of a square number. That becomes 2 times root 3. So root of 12 now simplified to 2 root 3. Let's have another one. Say root of 28. Root of 28. 28 is divisible by 4, which is a square number. Except 4, 9 cannot go into 28, 16 cannot go exactly, 25 cannot go, so 4 is the largest square number. I can write 28 as, and that would be 4 times 7. Again, as the previous exercise, I split but we know root of 4 is 2. 2 root 7. Another example, root of 72. You see, if you choose the biggest square number going to 72, getting to the final answer would be much quicker. Some people think 4 goes in it. Yes, 4 goes into 72. Some choose 9. I choose 36. But 36 is the biggest square number that can go into 72 twice. I split that as 2 surds. Root of 36 would be 6 times root 2. So root of 72 can be written as 6 root 2. Let's do this question the long way. You always get the same answer, but with more effort. Say, for sake of argument, we said 9 was the square number. Nothing wrong with that. So I'm going to split this as root of 9 times root of 8, which is 3 times root 8. 3 root 8. But you can see 8 still can be simplified. So 3 root 8 can be written as 3 root of 4 times 2. Now split 3 plus of root 4 times root 2. But root of 4 is 2, so we have 3 times 2 times root 2. 3 times 2 is 6 root 2. Something which I found much quicker there, it took longer. So my advice is always choose the biggest square number that you can fit exactly into that number. You reach the answer much quicker. Let's talk about now what happens when I multiply root of a by root of a. I'm going to explain to you why root of a times root of a will be just a. Root of a times root of a, I can write root of a to the power of 2. And you know, square root and power of 2 are two opposing actions. So power of 2 would cancel square root, and we have a. Or I could say root of a times root of a. I'm going to make use of the first laws of Surds. I can put them both as a multiplication of both together under one root, which makes square root of a squared. But again, square root and square cancels to give me a. Or I could say I'm going to make use of rule number 5 or law number 5 of indices. As before, when we write a root, we don't write powers of 1. So a is a to the power of 1. And when there is no number in the root, means the square root, means there's a 2 missing there. So by adding these or introducing these 1s and 2s, which we don't usually write, they're invisible, I end up with second root of a to the power of 1 times second root of a to the power of 1. Now I'm going to write these based on law number 5 of indices. And that was a to the power of a fraction m over n. That can be written as root of a here, m there, and n in the root, or vice versa. So if I have got the root of nth root of a to the power of m. I can write this as a, m as the top power, and n as the denominator of that fraction. So I'm going to do that here. So that can be written as a to the power of 1 over 2 times a to the power of 1 over 2. But first laws of indices, a to the power of m times a to the power of n equals a, and we add up the powers, law number 1. So here I can write a to the power of half plus a to the power of half is a to the power of half plus half, which is a to the power of 1, which is a. So I've explained how multiplying a root of a number by itself, you always end up with losing that root. So root of 5 times root of 5 is 5. Root of 10 times root of 10 is 10. More on simplifying surds. This time a combination of surds. We have root of 200 plus root of 18 minus root of 72. So there are 3 surds to be simplified. This one, root of 200, the biggest square number that goes into 200 is 100. So that becomes 100 times 2. 18, root of 9 times 2. 9 is the biggest square number that fits into 18. Take away, we've done root 72 earlier on, would be 36 times 2. Okay, now split them, root 100 times root 2 plus root 9 times root 2 minus root 36 times root 2. Root of 100 is 10. 10 root 2. Root of 9 is 3 root 2. And root of 36 is 6 root 2. 10 root 2 and 3 root 2, 13 root 2 minus 6, 7 root 2 is the final answer. One more example. Root of 80 minus 2 root 20 plus 3 root 45. When they ask you to simplify surds like this, often they all have the same common surds. Here they all had root 2, root 2, root 2. Here the biggest square number that I can divide 80 by is 16. I write 80 as 16 times 5. 2 lots of. Root of 20 would be 4 times 5. So you can see the 5 seems to be the common number here. And 3 root of 9 times 5. Root of 16 times root of 5, take away 2 lots of root 4 times root 5, plus 3 lots of root 9 times root 5. Root 16 is 4, so we have 4 root 5 here. Root of 4 is 2, times this 2 makes 4. Root of 4, 2 times 2 makes 4. Root of 9 is 3. And I'm multiplying it by 3, so 3 times 3 becomes 9 root of 5. Now we have 4 root 5 and 9 root 5. Actually 4 root 5, take away 4 root 5. All we have left with 9 root 5. That's the final answer to this question. Next lesson, we spend time on multiplying brackets involving surds, and then we go to rationalization of surds, the easy type and the more difficult ones. I hope you've enjoyed your lesson today on surds and simplifying surds. See you next lesson. Until then, bye.